We
And
finished the exercises also. Like we read up till the exercises.
yeah. Oh, we also did the exercise already?
What would happen if you initialize W? No. This is different. We read linear regression, but we have to start with implementation from scratch.
No, we did this already.
You did this?
Yeah, remember when we were debating about commenting out the epsilon here, the noise?
Yeah. Okay.
Do you
Okay.
remember or?
Yeah. Then we got like we got two like the curves. I remember.
Yeah.
Yeah. I think then initializing model, defining the model, defining the loss function, defining optimization algorithm. Can you go to that topic 6? No. Here, this one.
Oh, yeah. Yeah, okay.
Did we read this?
Mm-hmm.
I don't think we didn't read optimization, right?
Wait, let me check. We were debating about this one, the arrow.
The error, yeah.
And I think like we were we read until up
Oh, okay. We read.
until after the summary.
Okay. Then I think next is the exercise.
Okay. So if we would initialize the weights with a 0, it wouldn't work, right?
It would work like giving a constant value every time.
Okay.
Because the function will have a bias, right?
I mean, we can try it out, right? In the Colab. Oh, there's one more person. I hope it's not like I hope it's not someone who wants to troll, because yesterday I
Alex.
Hello, yeah, I don't want to troll. Don't worry.
okay. Have you been joining via the mail newsletter?
Hello?
No. Okay. Okay. Okay, so let's run the whole thing. Yeah, see, you seeing it, Lakshmi? That's the problem. So I'll just have to report them all. Yeah, Lakshmi, I just, when I saw the people were joining, I disabled that the people can unmute themselves.
You know what is this bug-like thing?
Huh?
What is the bug-like thing on my screen?
Yeah, I will remove it now. Someone draw.
It's a Zoom thing, or like were they actually join our session?
No, like the problem is there's like Zoom trolls. You know,
Oh,
there's
they
like, there's
just
like,
log in.
huh?
They just simply log in like that.
Yeah, they just log in and then they troll people. And I already last night I was trying to get some people to join, and then I posted a link on Twitter, and I think that's where things went south. I don't know, but so last night I already experienced that, and when I don't tick the box that people can't unmute themselves, like they will just unmute themselves and scream like insults and like
Okay.
yeah. I'm not sure what to do about it yet. Like there are some Zoom options there, but yeah, let's just continue for now. And like Zoom is a bit, Zoom is a bit annoying because um,
Yeah, I think that's why like last day when I was joining a meeting,
yeah,
they will send you a meeting only like 5 minutes before the session. So it was a meetup like in the meetup website we can join,
mhm.
but like when there is a like when actually before the program they'll send the link. Otherwise, so many people will that link just get abused. Maybe because of that.
Yeah, but they also will find ways to like. The problem is just like a link without a password, I guess, and
Yeah.
like now when people come into this room now here they will be muted, right, and they can't unmute themselves, so like they still can draw. Like I wonder what, like Zoom is a bit shitty. Like why can people just draw? Like why can't I disable that people need to get permission to draw? Like I don't know, I'm a bit dissatisfied with Zoom, but I think once somebody else would join here next, I will just ask them a question in chat. I'll ask like, "Hey, what's your name?" or something, and then to make sure you're not trolling, I have to ask you like a simple question, like, "What is deep learning?" or something. I will ask them how they would describe deep learning in their own words or something.
Yeah.
So this should be, at least we can like reduce the amount of threat with via this. Yeah. Okay, let's just continue.
Yeah, that's why their names sounded very like common names, Alex and Karim.
Yeah, yeah. Also last night I was like, there's a new user. I was already trolled before that, and then there's a new user called Bobby. Of course,
Hey,
that's a real person. Bobby. Okay.
I think it happened just after the mail you sent, right? So with the mail, did something happen?
Yeah, yeah, after the mail, right? But last night it was when I tweeted that link. Oh no, wait, it was also, did I send a mail last night? Yeah, I also think I sent a mail last night.
Yeah,
So,
I think so. It's a problem with the mail.
okay, so somebody could be in there and wait, I can actually track who clicked in the mail. Like,
Who responded?
Yeah, like it should be possible. But no, wait, here it says 0 tricks, 0 clicks. Hmm. Hmm. No, here it says 0 clicks. Okay. Hmm. Oh yeah. Yeah, but you're right. I think it's the email. There's some annoying internet. So here now we will initialize the weights with a 0, right? Zeros. Oh, again. Um, J21. Why is that?
Shape 2-1 is invalid for size 3.
Yeah.
Or 3.
I mean, shape 2.1 will have a size 3, right? No, 2. Oh, fuck. Like I just. Yes, I made a stupid mistake.
Unsupported for float and non-type.
Data substrate. Okay, so the problem is. Okay, so parent grad divided by wedge size. Yeah, okay, of course, if the
A gradient which is a non-type.
I think gradient of 0.
Yeah.
I don't think it's possible to compute a gradient of 0.
Okay. Okay. Yeah. So here, what have we assigned the bias B? Yes. Right.
Yeah, yeah. Like I'm pretty sure, like if I would change this to a range.
Arrange. Okay.
Floating point.
to once.
Yeah. Then no, still error. Mm, mm, mm. Mm. Okay, I will rerun this with the original documentation of the author to make sure, like,
I
okay,
think that like they need a normal curve itself.
normal curvature. Like now,
Yeah. Torch dot normal is used for W, right?
yeah,
So when we were using arrange, maybe like the gradient was not following any particular pattern or something that is not enabling for the back propagation, something like that.
okay.
Otherwise, like why should they use
Yeah,
only normal?
expect it to fail, like to have a large error and a large loss, but I wouldn't expect it to fail technically, like not on the implementation level. Like I would expect it to fail on the
Yeah, on a value basis, but not on a like in structure basis.
yeah. So I wonder, like this, like you can just check if this is the same. Like let's construct W1 and then like we did before, torch zeros, 2, 3, 2, 1, and then requires grad true. The same. And then let's see. Okay, so requires grad cannot be given to reshare, has to be given to the zeros. Thingy here. Okay, okay.
Should
Now
you
compare it.
W is a small value, W1 is a bigger value.
W1 is just zeros, like a tensor of zeros. And
Oh, okay, okay. W is
you see
a
this
tensor of two.
difference?
Yeah.
You see this one?
Grad function. Can you see the type of W1? Type of difference between type of W and type of W1.
Dot type? Or?
Yeah. It's a okay. One is a function, both a function, tensor type.
Oh, I thought the type is a function. Yeah.
George float tensor. Okay, both are tensor, but then there is a, I think, yeah, there's a difference in the way the gradients are stored in W1 and W.
Okay. Why?
Can you once again print out W1? Maybe we'll check, like Google out that term. Yeah, this one, view backward. Grad function equal to view backward. We'll just see what's that.
Like this? Or?
View backward.
Maybe torch tensor.
Use view on backward. Fail. Yeah. Use view on backward on variable cost backward to assign grade.
Phone is
What is that? You use on a variable. The variable's gradient would also be none. And okay, so what this guy found is that when you're using a view, when it is assigned like a view backward on a variable,
yeah,
the
yeah.
variables,
Variables.
yeah, the value of the gradient will also always be um, 0. Just see this link.
Okay.
I know my like the Zoom is very it's stuck mostly.
Yeah, I think Zoom will be over. The Zoom party will be over soon.
Yeah.
Uh, 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 what is it?
I wonder what happens to like there are so many people old age or who doesn't know much about technology now using Zoom, and then and then if they see somebody like this trolling, like suppose it is my family uses Zoom for a video call, right? Because
Yeah,
everybody is at home, they want to connect, like all the cousins, all they want to connect through Zoom.
yeah.
I can't imagine if somebody come and troll in that group, it will be weird.
Yeah, that trolling, like Zoom really has to take care of that. Like,
Yeah.
I think I can require people to have a Zoom account to join, you know? So that would put some barrier because then they would have to,
Yeah, but the benefit is like the one of the feature of Zoom is that you don't need an account. No, it's easily
then
available.
how, yeah, okay, but if you were like a product owner of Zoom and like, how would you make sure that there's no trolls um, given us like a room where it's possible to join without an account, like logged out? Like how to block the trolls without having an account or like without them having an account.
Yeah, and even I'm thinking. So one thing, like when I was talking to Jixi about this Google Meet, so the one thing with Google Meet is we will need a email account to log in.
Yeah,
So there comes the security factor. But that makes Google Meet like not popular among people, like people as in not technical people like you and me who knows about laptops and computers, but like for my uncle and aunties who they just don't know anything about this. They just receive their um, like link in the WhatsApp group, they just click it and they'll just use Zoom. That's what is happening right now. That is why Zoom got so popular, and because everybody is free right now, it
yeah.
just became but even for WhatsApp, the security, though WhatsApp like is very popular, the security thing came because it's connected to your Android or
To
your
the
main Gmail account.
yeah. Uh, yeah.
Yeah, the Chinese products will always have a loophole like this.
Yeah.
I just received a mail. I don't, yeah, I took this LinkedIn Premium yesterday, and then there is a meeting for, not meeting, a webinar for all premium users on how to use the features of premium. So
Yeah.
when I logged in itself, I got an email saying your Google account is accessible via Zoom. No, got access to Zoom, something like that.
Yeah.
So I think they are using Zoom to get a lot of information.
Okay. The LinkedIn or
The Zoom, because when I just registered for a webinar in LinkedIn, I'm getting a mail like that from Gmail saying that your account is accessible. You have given access to Zoom.
yeah. Ah, yeah, yeah. When logging in with via Google. Yeah.
Yeah,
Yeah.
I don't know. Maybe Yeah, the data security part, I'm pretty unsure.
Yeah. Well, I don't think Google is giving away that much information to Zoom. Like they're just giving the email address and then
Yeah, it should be only email address as of right now.
Zoom.
But yeah, this thing, the Zoom troll confused me today.
Yeah, me yesterday as well. But yeah, we will.
For a moment, I thought your system was hacked
No.
because it is your screen that I was seeing, right?
Oh, you thought I was drawing that?
Yeah, like not you drawing, but maybe first I thought like, oh my, that whiteboard has a new feature you can draw on the screen that you shared, like something like that.
I'm like, oh God, I have to think about these meetings with Manuel. Manuel seems a bit childish. Like
Oh, sorry.
you were thinking like I'm a bit childish with my drawings.
No, that's what like once your this plan gets over, we'll completely shift to Google Meet.
Yeah, we can.
This doesn't.
Yeah, maybe we can even like do the next session via Google Meet. Like I'm getting a bit annoyed with Zoom.
Okay.
So what you were finding is, I think it's the same thing as I did now. I did like a, maybe not the same thing, but now it's the same, right? It's for both. It requires grad true.
Yeah.
So I think now we can retry running this training loop. Okay, so it seems to work just fine if the... No, wait. No, I have to actually change this to W, not W1, because here we're using also W, not W1. No. So size mismatch. Okay, so wait. I think I gave the tensor the wrong shape. Here. This is wrong, right? It should not be like this is row vector, right? And we actually need a column vector. But yeah, it seems just fine with zeros. You said that at the beginning, right?
Yeah.
If we equal the weights to zeros, it will work just fine, you said?
Yes. Yes.
You.
So.
And I didn't believe you, so... Okay.
Because the bias factor is always there, right?
Bias factor?
The B value is always there. So when you are asked to explain on why you need a bias, the definition itself is like that is the state of your model when all the weights are zero.
Yeah, okay.
So it actually works.
Okay. So just wonder what's like the grads of W? Um
The grads of W when W zero.
yeah, like I think we can put it out here, right? W dot grad, print W dot grad.
My guess is it should be zero because it's a constant, right? No, it's a tensor with a small value again.
Wait, so I have to... If it would be zero, there would never be change, but Um, okay. Okay, so the grads are
Grads are a very bigger value when the W is present, and it is nearly zero when W is not present, right? That's the difference we saw. Okay, so
but when
gradient.
taking the derivative, like if the weight is zero, then
I think like the derivative is calculated as a combination of uh, Wx plus b. We are taking the derivative of Wx plus b, right?
of wx plus b in regards to w, right?
Yeah, so it will be x. Yeah, so b is a constant and
Is
it
is
should be
w,
0.
like, is the function we are taking the derivative of, is this like or L for loss, right?
Yeah,
L, and then W is the X value.
yes.
Okay, so it doesn't matter if it's zero, right? Because then this okay, yeah, okay, I think I get it. Okay. Okay, next one. So first exercise, what would happen if we were to initialize the weights to zero? Would the algorithm still work? So they were asking hypothetically, and you answered, yes, it would still work. I didn't believe you. I tried it out, and now
We know it works.
we also know it works.
Assume that you're using George Simon Ohm's law. Ohm's law is potential equal to voltage by current, VI.
Ohm's law, like
VI formula.
there,
VI formula. What is it? I forgot.
I don't know, like Ohm's law has
As a-
here. I is
Yeah, current equal to voltage by resistance.
okay.
So assume that it is coming up with a model between voltage and current. You can use auto differentiation to learn parameters of your model. So V equal to IR. Sorry. Yeah, V equal to IR should be the equation that we have to use here. And we have to find the loss function of like gradient of IR with respect to I. Here the weight will be no. R will be W, because when you do the Ohm's experiment, you keep like R is like the weight you can change. Actually, both.
Maybe you should take over screen sharing because I'm a bit baffled.
No. I'm just saying like that equation you saw, no? What in the Wikipedia, V equal to I equal to V by R.
Hmm?
You can rearrange and write it as V equal to IR, right?
Yeah.
So that will be our linear model. And they are asking us to auto differentiate it. V equal to IR.
Okay. V equal to IR.
So V equal to, in that, like you can consider either I as W weights and R as X, or vice versa.
Okay.
Like I'm not sure like if that can be interchanged, but that will be the function that we need to auto differentiate here. So if you want, like
Yeah.
can like I don't think
Let's skip this exercise. Or
Yeah, we'll skip that. Even Planck's constants is such a h equal to some new velocity. Frequency of light into Planck's constant is that is also one another equation. Yeah, 2 into Planck's constant into velocity by velocity of light squared. Again, if you see all these equations, we can consider it to be a model, a linear regression model, right? And this we can, and that is how we can use machine learning in different streams. Like this can be used in to find something with the experiments using light rays or something like that.
okay.
So that's what the two questions imply mostly. Okay. What are the problems you might encounter if you wanted to compute second derivative? Loss can be too small.
What is the second derivative?
It's like those squared.
Like the loss, right? The loss is like y hat minus y squared, right?
Yeah.
And then the first derivative would be
Derivative of loss with respect to y.
yeah, derivative would be 2 y, wait, 2y hat minus y, right? Is this correct?
Two y into y hat minus y. Yes, correct.
And is this what they mean? Is this the second derivative? Or would the second derivative be if I took a derivative of the derivative?
Yes.
But we
So
don't.
now you are again differentiating it with respect to y.
Yeah.
Or like if there is another variable, we can take the derivative with respect to that variable. Suppose there is x.
Like y hat would be w
wx x squared.
plus b.
Instead of wx, you can make it wx squared.
Y?
Because like if you
Whole
want to take
sorry, yeah.
no, sorry, yeah, this will work. So here the first derivative will be 2 into wx plus b minus y.
Yeah.
Now you can take a derivative with respect to x.
Okay, so derivative. Not w.
Sorry?
Not w.
You can do it with w also.
Okay.
So if you are doing with w, what will be the result?
The gradients, right?
Yeah, the gradient. The remaining factor will only be 2x because b and y are constants.
Okay.
Like earlier we were on the first derivative, we had differentiated with respect to y. So all the y terms stayed. And next, when you are differentiating with respect to x, the b and minus y doesn't have any x term, so they are considered as constants. On the other hand, if it was like the second derivative, suppose we derived it as 2 into wx plus b minus y whole raised to another 2.
Mhm.
Okay, if it was raised to 2, then we can have this wx plus b minus y term retained. I'll just annotate and show. So here, suppose if it was instead of 2, it was 4.
Instead of 2, it was 4.
Like raised to 4. Not this one. Yeah. Okay. Yeah. So now when you take the derivative, what will be the first derivative?
I think it would be 4.
4 into wx plus b minus y whole raised to 4 minus 1, 3. Okay. Now, next, when you take derivative with respect to w, your answer will be 12 into wx plus b minus y.
Oh, okay. 12.
12 into wx plus b 12 whole bracket, yeah, parenthesis, yeah, 12 parenthesis wx plus b minus y also inside the parenthesis
Okay.
into, no, plus
Plus
4w, no, 4x. We are doing it with respect to
W.
w, right? So 4x, yeah. So this will be our second derivative.
Okay.
So if you see for the question, for the second derivative, what are the problems you might encounter if you compute the second derivative? So if you don't have adequate powers or adequate values, your loss keeps on becoming low. It will like tend to almost 0. And it can go like undifferentiable also.
Okay.
Like suppose if the derivative was just constant b, on the first derivative was just constant b, means you cannot do a second derivative, right? It becomes undifferentiable.
So if the loss would just be b,
No, not the loss. The second, the derivative be b.
this was just b.
Yeah. Then you cannot further differentiate it with respect to y, right? The answer will be 0.
Okay, yeah. Yeah, okay.
So the more you differentiate with respect to like second differentiate, your loss value keeps on reducing, and at some time it becomes undifferentiable.
Okay. Okay, I was thinking that the gradients are the first derivative, not the second derivative.
Yes, gradients are the first derivative.
Oh, okay, but why are they asking for the second derivative?
Um, I don't like, even I was thinking why they asked for that, because back propagation means we don't use first derivative. No, we don't use second derivative. Only first
Yeah,
derivative is
this is a first derivative. So what is the meaning of this question? How is it related to linear regression?
We'll just Google how second derivative is related to
Okay.
linear regression.
Mm. For culture, the multivariable second derivative test. Okay. This is something. Okay, I don't think it's really.
Or I think it will be like, suppose you are doing an experiment, okay?
Yeah.
Experiment with lot of features, and with one feature you will do no. That is wrong.
I think it's just a confusing question to ask in this context. Like,
Yeah, I don't remember using second derivative in any. Maybe like we will see it in some of the architectures like ResNet or
yeah.
Alex.
Oh, yeah.
Maybe.
So,
Can you share screen?
oh yeah, yeah. So why is the reshape function needed in the squared loss function?
Yeah, to bring it to same size, right? Same size as of the x vector.
Yeah. Yeah, I asked you that as well, right? Because you already explained it last time. Why? Why? Oh, yeah, the one is a row vector, the other is a column vector.
Yes.
Okay. Um, Experiment using different learning rates to find out how fast the loss function value drops. Experience using different learning rates. Okay. Different learning rate. Where was the learning rate? Oh, it's in the here. It's here. So this is the normal learning rate. There we have a loss of 4 or 4.
Yeah, this you remember, right? I showed you the graph where it will come to the lowest point at different. I used yellow color, red color, blue color, and I showed the graph, right?
Yeah. Yeah.
If the learning rate is very small, means it may not reach the low minimum point, minimum error point.
Is this low enough?
I can't see your screen.
Oh.
So we cannot we cannot say
Low enough.
is the yeah this is like very small, and even with 3 epochs you won't reach that loss. See, the loss has
Somehow it's still really good. I wonder why. Oh, because the weights were already. I need to. Right. Yeah.
okay, loss is very big. So you have to, this is why it is important to check the parameter epoch and learning rate. Like we cannot, I was once training something and I just use 100 epochs. But using 100 epochs is not an efficient method. You should use the right combination of the learning rate and epoch.
Okay.
See, you just removed 1 0 and the loss has come down only a little bit.
So no, I didn't even change anything. I just rerun, but I can reduce some. Like it doesn't change at all, right? It's just like depending on the random assignment of the weights,
Yes, yes.
it doesn't change anything at all. So, and when I make the learning rate really big, like a 5,
Then it will soon reach conclusion and then it might go up.
not a number. Not a number. Why? It says loss, not a number. Maybe it has to be sub-zero. Oh, you muted yourself, right?
Yeah. I just got a sneeze and then I muted it.
Oh, okay.
Yeah, so what happens is the loss has reduced to a very small value, or it reached the minimum point. It reached the minimum point, like it's in that, what is it? Dung point, right? When the learning rate was 5, it immediately went to the derivative became uncalculable. What do you say? Derivative could not be calculated because it reached the lowest point.
With a high learning rate, or?
Yes, with the high, when you were using 5, you got NA in values, right?
Yeah.
So this will, what will happen if you use second derivative also? Like NaN is coming because the derivative is being calculated with respect to 0. Like your denominator will become 0 and that is not calculable, right? That is why the error is becoming NaN.
Okay. Okay, so, and then what's the highest number I can go? Like 1?
You can try 0.1, 0.1, 0.9.
Like 1 works.
But even 1, the loss is, yeah, okay.
And 1
Yeah,
works.
loss is good. Okay, 1 work.
Infinity, okay.
Yeah, that's what. The infinity came because division by 0 has come. Anything divided by 0 is infinity, right?
Why is it not a number for the other thing?
That's what. When the loss is calculated in the back propagation, inside the loop, some division came where the division denominator was 0. That is why INF came there in the third epoch.
Yeah.
So when you have all the epochs like that, they are replaced, like giving the value as NaN.
Okay.
The same thing will happen when you take second derivative, because your loss has become so small.
Do you think the other question is related to this? Okay,
Yeah.
so the next epoch when the loss was infinity before it gets not a number. Okay.
Yeah, when you are differentiating an infinity with with 0, this will become NaN. In Python, like division by 0 is infinity, and division with infinity is NaN. Okay. Yeah, if the examples cannot be divided by batch size, what will be data iter function's behavior? It will be random, right?
Cannot divide it by the batch size.
If it is not wholly if it cannot be divided wholly by batch size, it will give a random choice.
No, like wholly divided, but then wait. It's shuffling the indices here, and then I think they're referring to this one, the minimum. Then
Yeah,
there will
so
be one
always,
batch. The last batch will be smaller than the other batches.
yes, correct.
Um,
Yeah, so the last one will have only, suppose like all the batches have 10, but the last one will only have 9 or 8, something like that.
yeah. Okay. And then there is a comment section. And there's a comment by Mandela from already over 2 weeks ago.
Yeah, you remember he had reached chapter 4.
Oh, did he say he read up until chapter 4?
When we started the
Oh, yeah, memory. I didn't remember that.
yeah. Mandela should have seen the bug, and he would have had something to say about it.
What?
No, like he always have, when he see pictures on the whiteboard, he can relate it to many what do you say? He can relate it to many shapes. Like we might not think about that shape, but he related to many shapes.
Looks like in SGD function we should divide parameter.
Angry you. Angry row. He's very angry.
Angry Roo. Oh, I actually asked for answers, and then I got a reply that the exercises and videos and still in production. Lol. I don't get, like, is she referring to that?
Maybe she is referring to like the exercise itself. They are in like probably the, what is it, solution videos are in production.
Yeah, I also understood that at first, and I was already
But
excited to hear the news with you. But now that I'm rereading it, it's like the exercises and videos and still in production. Oh.
okay, it might be like exercise solutions, and maybe they are for the course they are building videos, maybe.
Okay, and then while we do have videos from the Berkeley course, so where? They have videos here, she said. Oh, I
But
should
videos
not
like we
refer
have.
to, like if I don't know them, I should refer to people as they, right? And them, like not
Yeah.
to assume I can refer to them as she or him, like I should use they. Oh, okay. So here they have a video.
Okay, like in the
Like,
initially when you ask what you would like,
yeah, yeah.
um,
What do you,
what you would like to refer means, then I thought you had some doubt, like if I have any gender confusion.
no, it's just no. Okay, no, like just to make sure, because it's also a common practice on Twitter to put like the pronouns a person would use in the Twitter bio,
Uh-huh.
and it's not really related to gender directly. Like,
Yeah, some people like to be called as doctor or some as professor.
yeah,
Like,
no, it's not really about that. It's really more about they and um, they, them versus. Um,
so this is the same that we same code that we are using, right?
is it though?
I think it is.
I think it's the same code. It's just MXNet.
Ha ha ha.
You're free or by no reasons. I can tell you if you want to do the things. Because
But there is already at the.
But I don't think I'll have the patience to listen to all this.
No, me neither. I'm just searching for if he's
Giving the answers. Okay.
giving the answers to the.
to render now.
Okay, so the book and their videos are also there. That's good to know.
Initialize to render number. Very large loss. If I gonna use a very large one, this one.
Okay, let's move on.
Yeah.
0.03 is too small. Let's do.
I can't have these many tabs open in my laptop.
As I have, or
Sorry?
as many as I have open, or
Yeah, if I open like beyond 7 maybe, then the laptop gets stuck. And to
oh,
add on, like with Zoom, I can only have one or two maximum.
really?
Yeah, there is some. I need to buy a new one.
Wait, what's the?
I think because it's Mac for you, it is good. Like the
Yeah,
performance is good.
yeah. It's also it's not an old Mac, like it's a fairly new one.
Yeah.
Here it's 6 core. And it got a big like it got a graphics card in addition to this one.
Okay. Okay, so you can actually run CUDA on your laptop.
No, like wait, let me show you the graphic card system information. Huh? Here, and then graphics. It's a Radeon Pro, so it's from AMD. It got 4 gigabytes of VRAM, but I would have to use this one, Plate ML. It's by Intel, and then it only works with Keras, not with PyTorch.
So this is like you'll have to add a extra hardware.
If I no, if I would want to use CUDA,
Okay.
yes, I would have to like get a USB graphics card, but I also would need to use Windows or Linux, and I can't really install Linux because it doesn't work with the newer MacBooks anymore. So I can only use it with Windows.
Yeah, that will be like a virtual environment, and the performance could be low.
No. It will not be virtual. Like on the MacBook, there is something called Bootcamp.
Okay.
And then Bootcamp installs Windows natively.
Okay.
But yeah, but I think we can just use Colab or Cloud
Yeah.
Offer.
Today there is a new video from Kaggle on how to use their TPUs, because Kaggle offers 30 hours of TPU for 1 month and
Okay.
3 hours continuously for a day.
Okay, so I think that's where also, but I think this is clear for me, right? That
Yes, yes, correct. They take derivative with respect to W, not with respect to inputs, because W is the changing factor here. Inputs are constant.
yeah.
So only when you, every time you take a derivative with the variable that keeps on changing, because you need to, derivative is always a rate of change.
Okay. Okay. So is there anything more interesting in the discussion? I think he was trying to solve the Max Planck.
Planks. Yeah, Planks.
It's funny, like some setup of yours always sounds like you're slurping a smoothie. Like always sounds like
I'm actually drinking coffee, maybe not.
through a straw.
No.
No, okay. No, it sounds like you would be drinking something through the straw, like a Starbucks smoothie or something. But I think it's just that it's another sound source. Um,
Interesting.
okay, so I don't understand the relation between. I think we can move on.
Yeah. I think everybody in this section, there are a lot of comments, because once they reach the linear regression, everybody tried to build a model. Like even we were coding more on this, right? We tried out.
Yeah, it gets more interesting. Yeah,
Yeah.
it's like now it counts. Okay, I read this as get rich first, and you read this as angry you, right?
Yeah, even I read it as angry you
Angry
also.
you. Get
The R between Y and O is so, it's like,
so weird name. Okay,
that is a scientific way of saying it. Like,
angry you.
not deceptive. No, I don't remember.
Get rich.
Okay, next is
Concise implementation.
concise. You can read?
I should read.
Okay, I'll read. Concise implementation of linear regression. Broad and intense interest in deep learning for the past several years has inspired both companies, academics, and hobbyists to develop a variety of mature open source frameworks for automating the repetitive work of implementing gradient based learning algorithms. In the previous section, we relied on first, tensors for data storage and linear algebra. Second, auto differentiation for calculating derivatives. In practice, because data iterators, loss functions, optimizers, and neural network layers, and some whole architectures are so common, modern libraries implement these components for us as well. In this section, we will show you how to implement the linear regression model from the previous section, concisely by using frameworks high-level APIs. So in PyTorch, the first one is getting the data set. To start, we will generate the same data set as in the previous section. So we are importing the D2L library, the NumPy, Torch, and Torch utilities to import data, and true weights. The true weights here are tensors, 2 and minus 3.4, and true bias is 4.2. The features and labels are synthetic data from the D2L library with true weights and true bias. 1,000 examples, right?
Yeah, okay. I was also wondering, but now, yeah.
Yeah. And the labels are, okay, labels need to be reshaped as -1, 1. -1.
-1, -1 means like what like dynamic sized.
Okay, dynamic size, but a row vector.
Yeah.
1 minute, I'll just take a call. I'll be back. This is
Hello.
terrible. I'm showing you actions like unmute, unmute, but you can't see me.
I can see you.
No, because I think my video was not on your sidebar. I'm showing like unmute, unmute, but you can't
Oh,
hear me.
okay. I will see it in the video when I upload it to YouTube. I can look. It will be fun.
Yeah, this unmuting is very irritating. Okay, yeah,
Yeah,
read on.
but I will leave it like this because I really like yesterday. I was really you know this game called Whack-A-Mole?
No.
Wait, let me show you. Whack-A-Mole. This one, like you have to like
Okay, we have to hit on the head and then it should go inside.
Yeah, and then they appear at random places.
Yeah,
And
yeah.
then yesterday I was muting the people, and then they could unmute themselves, and then they were screaming insults at me, and
yeah, that's very irritating.
and then I felt really cyber bullied. No, not really. Okay. To start, okay, the data
So
set.
it's
This is
still, I remember like 10 years, 15 years back. Oh
yeah.
my God! When the Orkut was there, I used to chat with unknown people, and then it used to be really not interesting. Cyberbullying was too much.
Yeah,
I
like
was
which platform was that?
Orkut,
Orkut.
Orkut. Before
Um,
Facebook, we had Orkut, right? Orkut, O-R-K.
Orkut. Yeah, yeah, yeah.
Yeah,
This was joined into Google, right?
yeah.
Oh, this guy named this after his first name. Quite a bold move. His first name is Orkut.
Oh, I didn't know that. He was Turkish. Okay. So yeah, Orkut, and then I didn't know. I was too naive to with the cyber things, and then
Yeah,
one guy
yeah,
like he said he'll come and meet me. I was so scared.
yeah. Okay. Mm. Yeah, the internet is still, and like, I would think they would have solved this by now, but still, with a new app, Zoom, it's still a current issue.
Yeah. Even like if you are publishing to YouTube, like I publish some of my works for portfolio purpose, and you see like lot of comments are coming from machines, not from real people, and
Mhm.
they just use bad language. I don't know why YouTube is still not progressive enough to
Yeah.
bar them.
Mm. I with the videos I'm uploading, I'm always checking the option that I review the comments before they are published, and I'm also
Okay.
always disabling the likes and dislikes. Yeah.
Yeah, it's very funny because even before your videos are live, you will have dislike on it.
Yeah.
So
Yeah.
it's
Yeah.
really from a machine, not from a human.
Or just trolls, or like just teenagers. Like it doesn't even have to be machines, but
Yeah.
yeah.
And I seriously think about them. What pleasure do they have in coming and trolling like this? Don't they have anything else to do in their life?
Yeah, I mean they're teenagers, so I don't know. I got a comment on this video, and then no, it's not there anymore. Wait, was it actually this video? Maybe it's deleted by now. Hmm. No, I can't find it. Oh no, here it is. Oh, okay, this was actually deleted. Um,
And this looks like from a real person. Like his channel is
this
very
one?
real.
No, I mean this one by Lion. You see it, Lion?
Yeah. Never give up. Oh, okay.
And then I replied like, see, it's deleted now. But I replied like, how can we be YouTube friends? Like he said, let's be YouTube friends, right? And then I checked his channel, and then and maybe you know it, but on YouTube there is no such thing as like friendship, right?
Yeah,
Like
there is no.
I didn't know that, so I was like, how can we be YouTube friends? And then I realized like he's probably not a real person. And seems YouTube deleted that now. He also had quite a big amount of subscribers, so I guess that's how he grew his YouTube channel. So he was like just wrote
YouTube friends.
wrote the bot to comment on people's new videos, and then yeah.
Yeah. Okay. Continuing.
Mm-hmm.
You can read.
Yeah. Reading the data set. Rather than rolling our own iterator, we can call upon the data module to read data. The first step will be to instantiate an array dataset. This object's constructor takes one or more tensors as arguments. Here we pass in features and labels as arguments. Next, we will use array dataset to instantiate a data loader, which also requires that we specify a batch size and specify a Boolean value shuffle, indicating whether or not we want the data loader to shuffle the data on each epoch passed through the dataset. Okay.
So what, I'm confused. Data is a library? Data dot tensor data set data. Where did we define data?
Here, torch utils. From torch utils import
Torch
data.
utils has a import data. Okay. And it uses data dot tensor data set. So the input is an array. But they mentioned about features and something else, labels as arguments. Where is that?
Here it was. This.
Okay, I'm getting it. So we can actually pass more than one tensor, but right now we are only passing data arrays tensor. And that data array will consist of features and arguments and labels as arguments. Got it?
Oh, okay, yeah, the data arrays. Thingy.
Consists of features and labels.
Features and labels, okay. So this is like concatenating two lists.
So actually, if you see here, there are two steps. First, the constructor is formed with data set equal to data dot tensor data set. Then the loading function is happening in the return statement.
Here, okay. Oh, okay, and then they use is train. So, okay, so if it's a training data set, then they shuffle it. Because I was wondering why, when would you not want to use shuffle? So, but then it's
For
obvious,
test.
a variable
For-
naming. Okay,
Yeah.
yeah.
So, and okay, the data iterator will be load array. Okay, that function which you call by passing the features and labels.
Okay.
1 minute. So you are passing. Oh, okay. You are passing an array by sending features labels inside one parenthesis and the batch size.
Yeah.
Okay, so okay, got it.
Yeah, I'm also confused, or not confused anymore, but I was confused
Why
because I
double
never did.
parenthesis?
Yeah,
Even
yeah.
I've never used that.
Okay. How we can use data iter in much the same way as we called the data iter function in the previous section.
Okay. Previous section we were loading it one by one. As in we were using arrange functions and all, right?
Yeah.
Data
Here.
iter set search for data. Yeah. We were using for loop and then.
Oh yeah. And then yeah, like a self-written version of the iteration. Much the same. Okay, so but from the usage, it's the same. But I guess it's implemented a bit differently. Yeah.
Yeah, so these data loader and data tensor data sets are inbuilt functions of PyTorch.
Built in, yeah.
Yeah, built-in functions of PyTorch.
It's like the Yeah, yeah. I was just wondering because in Germany it's also the other way around. It's also inbuilt. So in German language, like I was wondering, it's the same in your native language, so maybe that's hence the
Yeah,
confusion.
they use like the problem with Indian English is we have Europe and US everything mixed because we never learned it as our first language. We
Yeah,
heard from somebody who came from Europe or the America.
yeah, yeah. It's the same for
We're
me. Yeah,
confused.
it's also not my first language, English.
Mhm.
Okay, but it's
But your
everything
first
is
language is very like almost similar to English, right? Like German.
German. Yeah, yeah, yeah.
It's
But for like built in, it would also be other way around. It would also be inbuilt in German. It would be eingebaut. So
so. Do
um,
you understand like when you only knew German, you could easily understand English?
no, you mean it made? I don't know. I don't have the reference. I don't know how it would have been if I didn't
No
like
English. Okay.
yeah. But could be that this made things simpler. Yeah, without me noticing. Not consciously though. I didn't notice that consciously.
Okay.
To verify that it is working, we can read and print the first mini batch of instances. Comparing to section 3.2, where we section 3.2.
The previous one, the one you opened with for loop.
Oh, okay. Here we use iter to construct a Python iterator and then use next to obtain the first item from the
Yeah.
iterator. Okay.
In order to obtain every element, we need to use iter to iterate through the data set, and to get the next value, we need to
Okay.
use next function. Okay.
And in the previous section, like we were using
For loop, right?
for loop. Oh, for in data iter. Okay.
Yeah.
But we could use the same here, right? We wouldn't have to use this. Like this is not obligatory. Wait.
This they are trying to make it in one line.
Yeah, I think that it's just to show one, like the first item in the iterator.
Yeah, but this would be an expensive function. So when you like, this is the problem. When you go to a company, they don't allow you to use all these, even though it is
Okay.
very optimized. They say like, no, we can't use this function. It's very costly. It will take GPU, no, more of storage, etc. For
Okay.
example, like in SQL, there is a function called case statements. It's very easy to use case statement, but whenever I write a
SQL.
query, yeah, SQL.
Um,
So
this
it's
one.
like it's an easy function, no? Like an if function. When
Hmm.
the condition is, then the result is this.
Yeah.
So that's very easy to implement, but in my company they never allow me to use that. They say you have to use subquery after subquery. So
Subquery after subquery.
yeah, like you have the same thing, you need to think and implement it in some other way. Like the subquery, you need to write a select statement inside a select statement.
Okay.
So they always prefer that, because but I think every company should scale to that level to use a case statement at least. Otherwise, why do query languages have all such things?
Yeah, I mean, he's also here. The accepted answer is like it depends, right? like there's not like one truth,
Yeah,
right?
if you only have the right index, this will work.
Like I'm not very I know how to use SQL, but I don't know a lot about performance. Like
Performance is
not
better for case, but I don't know. This is the problem. When you're using a subquery, you need to first create an index and then create a new table. So many processes involved. But suppose you have one table and you need to just query from that. Why don't we use case statement? So it's like there is no point in arguing with them.
Yeah.
Okay, move on.
Yeah. Defining the model.
Yeah, defining the model. When we implemented linear regression from scratch in 3.2, we defined our model parameters explicitly and coded up the calculations to produce output using basic linear algebra operations. You should know how to do this, but once your model gets more complex and once you have to do this nearly every day, you will be glad for the assistance. The situation is similar to coding up your own blog from scratch. Doing it once or twice is rewarding and instructive, but you would be a lousy web developer every time you needed a blog. You spent a month reinventing the wheel. For standard operations, we can use the framework's predefined layers, which allow us to focus especially on the layers used to construct the model rather than having to focus on the implementation. To define a linear model, we first import the NN module, neural network module, which defines a large number of neural network layers. Note that NN is an abbreviation for neural networks. We will first define a model variable net, which will refer to an instance of the sequential class. The sequential class defines a container for several layers that will be chained together. Given input data, a sequential passes it through the first layer, in turn passing the output as the second layer's input, and so forth. In the following example, our model consists of only one layer, so we do not really need sequential. But since nearly all of our future models will involve multiple layers, we will use it anyways to familiarize with the most standard workflow. Recall the architecture of a single layer network from 3.3.1 figure. The layer is said to be fully connected because each of its inputs are connected to each of its output by means of a matrix vector multiplication. That figure is understood, right? It's a neural network where there is an input layer and which is connected to output layer using a matrix vector multiplication. What will be that matrix vector?
Yeah, I was gonna ask that as well. So the vector would be the weights, right? And then the matrix would be the inputs.
Yes, correct. Correct. So here we will implement using torch, torch library, not library, torch NN network. And the network will be NN.sequential. Okay, we are using neural network sequential layers, and in that NN lot linear, because it's a linear regression, where there are 2,1. Okay, here we are using 2 inputs, I think.
Two
In
inputs.
Gluon,
But sorry,
yeah,
but why
that,
sequential? Like it's only one layer.
yeah, that's what they are. We are using it just because
Oh,
to familiarize. That's what they said.
where did they say that? Sorry, do you remember?
The second paragraph, last
Yeah.
line. We will use it anyway just to familiarize with the most standard workflow.
Oh, okay. It's just oh, okay, okay, okay. Okay.
Yeah. In gluon, the fully connected layer is defined in the linear class. In gluon, the fully connected layer is defined in the linear class. Note that we pass two arguments into NN. NN dot linear. The first one specifies the input feature dimension, which is 2, and the second one is the output feature dimension, which is a single scalar and therefore 1. Okay.
But why in gluon? Like
Gluon,
it's not gluon. It's PyTorch.
yeah, in
Maybe I
Python.
think I will do like a typo thing on GitHub. What do you think? Or would it be too? Would you be too bored?
You want to change, or you want to keep a reference?
Like make a GitHub pull request and change that to PyTorch.
Yeah, you can try that.
I mean, it's very subtle, but
But
oh,
like everywhere where they used MXNet, you have to change to PyTorch. Gluon needs to be changed to PyTorch. Similarly, next anything that comes up, you need to change to PyTorch.
yeah, I'm just not all of them, just this one.
Yeah, just Gluon. I
Just
think
this
you can.
one. No, not even just this one typo.
Oh, okay.
Just like a really small
Thing.
contribution.
Contribution. Okay.
Like you're even laughing at the word contribution in this context. I feel
No, but they say,
cyber bullied.
no, they say, right? Like for every repository, the best is to start with documentation editing.
Yeah, that's true. Oh, I got a new follower. So GitHub here. And then chapter linear networks. Linear
Concise.
regressions. Oh yeah.
Third last. But there were two concise. I don't know which file. They were same thing twice. 4 days ago.
This one is softmax. This is a whole other chapter.
Okay.
And then reading the data set, defining the model.
Is it the PyTorch version that you took? In Gluon. Yeah, this one.
I think they're both in the same file. Like
In Begin tab.
PyTorch in PyTorch.
But they have written here PyTorch.
Yeah, it's fixed here. And then they didn't redeploy the website, I think.
I think it's not pushed to production.
Yeah. Oh, see, there's even a new tab. There's also TensorFlow for the next version.
Mm-hmm. Maybe
So
that's what she was saying. Exercises are in production.
Yeah, they're probably doing a lot of stuff still. How can I see the commit history for this file here?
They have changed Gluon to Concise.
Oh, okay. So this is actually very recently that they are making this multi-version. Okay, let's just. But I wonder, how can we read like the most current version of the book?
They have to deploy. Without that, we can't do anything. Otherwise, you have to take this GitHub and then you need to host in a new server.
Mm. Mm.
Actually, yesterday I had mailed you, right? I wrote a pipeline.
Yeah.
Yeah, the pipeline was similar to this one, but I did it in sklearn. So now when I
Okay.
read it, I can really like correlate both of them.
Similar to this one.
Yeah, so instead of data loader, yeah, they have a similar function called data loader. For neural networks, there is another function. So there is a feature called pipeline. So when you define a class called pipeline, you can give all the steps in one by one, and it will do it by itself.
Okay.
So when you are going for hacker rank, some competitions, yeah, this one.
This one. Okay. Oh, so it's like the sequential thing, or?
Yeah, sequential. Whatever you give an order, that it will be done. That it can be data pre-processing that you want to do, or loading the model, or predicting the model, doing the verification. Everything can be made to a pipeline.
Okay.
So when you have that structure in your hand for the hacker rank competition, you just need to put that function and change the variable names according to what the data they have given.
Okay.
So within, like, they'll give you almost 3 hours to complete the challenge, and in 1 hour it will be done.
What do you mean? In 1 hour it will be done?
Like they will think like you need to sit in code, write the code for every single step. But if you have the pipeline already in your hand, you
Oh,
need to,
okay.
so that means like you will ace the challenge.
But it like isn't that against the rules of the challenge?
No, but a person who have only that much of knowledge can use pipeline and change the change it according to our own requirements. Because suppose like for one data you may not need one hot encoding, you might need label encoding. So only a person who knows all this can change the pipeline.
Hmm. Well, I was already
Currently,
looking.
like, yeah, currently in India there are no competitions for AI. Like, they have an AI section here. You can sign up and for developers, log in.
I was
That's all.
wondering the one you used. You used this one, right? HackerRank code pair, or no?
No, I just logged in and I was checking for the artificial intelligence exercises.
Oh, here you mean?
Yeah, the sign up and code, I already had an account, so I'd log in. Yeah,
And
in this
then
there are artificial intelligence. There is a oh no, just go to compete on the tab. Compete,
oh,
top
okay.
one. And just there is a, you can tick on the side artificial intelligence. Yeah, top, yeah, data structure, mathematics, artificial intelligence. Okay, even your area doesn't have any competitions on that, but there are exercises for artificial intelligence.
Wait, this is by area?
Yes, it is by area, because some competition happen on weekend only for India. It is company country wise mostly. But what the, like, whatever I got was from a US company. They had their own test link.
Okay, but and it was. Did you find it via the compete tab or?
No. That for the one, the recruiter has sent me a separate email.
Yeah, that's what I was wondering. So what you were using is like let me check, marketing.
But usually for full stack and all, they have competition. HackerRank has competition. Just that
So
with AI, they are not well. Like they haven't started competitions with AI.
so you were using this one, the code pair, or the code screen? Do you know which one it was?
Let me just. I'll check the link again. Maybe it will have. It took me to a Jupyter notebook. Whatever
Did you?
the link they sent me, and I had signed up with my name, and
And it
it
was
took me to a
it was
Jupyter notebook.
HackerRank.
Yes, it was under HackerRank, but they had a something like a virtual inside the virtual environment inside the HackerRank.
And do you see this one here, proctoring
One minute.
control?
One minute. I'm getting hackerrank.com test CEFDTIN login. No, I'm not able to recognize with the URL.
Okay.
Okay.
So they have like a thing called proctoring control, detects when a candidate leaves the tab.
Oh, detects when the candidate leaves the tab.
Yeah.
But I did not use any video.
Yeah, I was just like, I was looking at this before when you told me, and I was like, I wouldn't do that. Like, I was like, that's not like, I'm not a lab rat, you know. I'm not.
No, because when you want to do something, we need to change the tab and Google, right? Like you cannot write everything from the head.
Yeah, right. I don't want to work for a company that's trying to detect when I'm leaving a tab. Like,
Yeah, one thing
no
when
thanks.
exactly what I noticed was whoever is using HackerRank as a screening test, right? The company is not very great
Mhm. Yeah,
because
like,
they don't get the real intellectual minds.
yeah, like they're
Because
also, yeah, sorry.
because a time test like 3 hours for a data model is utterly rubbish, because when you take time, like I used to write models, they used to give me around 3 days. It's on your head and you'll think over and over about it, even when you eat, drink, or sleep, you'll think about it and you improvise it, and then finally you submit. And that's why like Kaggle competitions are across 3 months almost,
Yeah.
and that they cannot do it in 3 hours. If you like, I don't know. So I don't prefer, like if I'm having a company, I wouldn't use HackerRank
Well,
to hire people.
they will find candidates who will be really good at memorizing
Exactly.
existing solutions and then typing them, and then, but that's like, I don't know. Okay, so data itar, no, this one, scratch, concise, okay. Oh yeah, we were thinking about how to use this in the most current version. And but they don't show, oh, there is contribution, and there's probably like set up by, I think you remember the one person from the meetup where there were many people, and then he said he's running it on his own Jupyter book, a Jupyter notebook.
Yeah, so if you run the setup.py in your environment, maybe this will you like you can create a new HTTP address for yourself, like on a local server.
Yeah, I guess
That
so.
is
Like, um,
already my system is
but
on
they don't,
version.
huh?
No, my system is already like a tortoise. I don't want to run a setup.py for a notebook, no, for a book.
um, they don't show here how to run it. Building. Oh, here it's building. Building HTML. So it's D2L book build HTML. I mean, this seems pretty straightforward. I think I will just do it.
Yeah.
Mm.
Tomorrow night, like we have the 21:30, right? I won't be able to attend even that. Tomorrow is Wednesday, so we will like from your 11:30 to your, I don't know what time. Yeah, what is the time right now?
Local time here is almost 3 p.m.
Okay, so we'll try to do it like from 11:30 to this time, 3 p.m.
Okay. Yeah.
Because tomorrow I'm trying to do a podcast with one of my seniors in college.
Okay. You will do it like a video or like an audio podcast?
I wanted to do it as a video, but then the college doesn't want it to be a video. Even my
Why?
senior wanted to be a video. So we are
Oh, your
using that.
college.
Yeah, like it's a podcast for alumni, because now we are like, because of the lockdown, people have time to talk. So like this friend of mine, she was trying to get into Harvard, and then she have a lot to talk about all those stuff.
Okay. And then I guess they're saying it should be an audio podcast because of the low bandwidth some students might face, or
Yeah, no, because they're focusing mostly for Spotify. Like YouTube version is not encouraged.
oh, they will upload it to Spotify.
Yeah.
Okay. Spotify is getting like a bad reputation lately.
Mm-hmm.
Like they should upload it to Google Podcasts. Google Podcast is very good.
The problem with this Google podcast meeting and all, they are they're not popular among the common people. On the other hand, because Spotify only focus on podcast or music, it it is easily identified by the common crowd.
But
But
for
when
Spotify, sorry, but for Spotify, I need a premium account, right?
no, you can for like 30 minutes, 40 ads will come, but you can hear it. No
No,
problem.
but for offline, like I don't have internet on my mobile when I go out.
Okay.
So I usually use Google Podcast so I can download music before I leave the house, and then I can
Yeah.
listen to it offline. And with Spotify, I can't use it because it's a premium feature.
Yeah. But Google also is a premium feature, right? You need to have a paid Google account to do that.
For Google Podcast?
Yeah, because in my I have a Google Home that I got as a, like I got it as a free from when I attended one of the Google events. So whenever I try to download music in that, they say I need a premium account, premium account.
No, but it's a different app. It's called Google Podcast,
Okay.
not Google Music. Like Google Music is paid, but Google Podcast is for free.
Okay, I'll try that then.
So they're giving like instructions for Linux here, so I think it's more interesting, or it's easier.
So will it not run on your Mac?
I don't know. Pandoc. Okay, so maybe I don't even need Pandoc for the HTML. D2L book build HTML.
No D2L found.
Oh yeah.
Yeah, I'll just use the washroom and come. I'll be
Yeah,
back.
yeah. No, I gave up. I gave up.
It didn't work?
No, like I'm trying to install Python and it's already installed. And then, oh, it's actually installed, but pip doesn't work.
You have to
Pip3.
install pip.
Oh no, it's
pip3.
pip3. It's the same, right? Pip3.
Oh, I never used pip3. For me, every time pip works.
Okay, so I guess I can try with pip3. Pip3.
Okay, it's downloading.
This is already taking.
Now the setup is running.
Oh, okay. Is it usually longer than the downloading?
Sometimes, because it needs to like internally install something.
Okay.
But since it's just an HTML, I don't know why it should take long.
I think it's um,
These are all Python packages.
Yeah.
Alabaster, IDNA, certify, sharded, request. And the last one, D12 books.
Indetectable. Snowball, stammer, sphinx.
Successfully installed Jinja. Figman. Sharded. Oh, they are letting us know the version. So can you come down? Maybe D12 book also version will be specified.
Here,
No.
somewhere inside of here.
Yeah, no, it's not there.
Oh, no, grep only works online, so, or at least without additional parameters, it only works on lines. To import D2L, Python, permission denied.
Sudo? Maybe you need sudo.
That's usually bad practice, but I'll just use sudo now. Invalid syntax. Oh, is this maybe some Python version mismatch thing? I have, okay, so.
You have 2.7?
I have multiple versions of Python installed. So I think I need to run Python 3. Setup.
Yeah, this is very confusing. It happens to me.
Yeah, it's. I probably should use like a PyEnv thingy, like a Python version selector. Well, that seems to work. And then
Build.
HTML. Looks
No, the
good.
PDF, you could, yeah, okay. Build PDF will build a PDF file for you.
No, but I would never prefer PDF over.
Okay, no module MXNet.
What? Why do they need MXNet?
I think
Oh,
they'll only do it as a combined form.
are they running the code actually? Like
Python 3.
pip3 install MXNet.
Oh, the book get installed only in a combined form.
Yeah.
With both MXNet and PyTorch. Okay, because they are downloading all the MXNet libraries.
Here it says executing notebook with kernel. Python. Oh, I guess this started a Jupyter server, right? No.
Yeah, it has a Jupyter snippets in it, right? Maybe because of that.
Well, I think it's
for the collab.
It's running. Oh, it's running. Okay, this is quite time consuming. Like, it's running the notebook for every chapter.
Okay.
For every section of every chapter. And you see how long this takes, right? This is just like we're just waiting for one section.
Yeah, maybe you can keep it for tonight.
Yeah, yeah.
Or let it run in the background. We'll continue with us.
Yeah.
Okay. Anyway, this recording will be very helpful. It has installing D12 book also.
Here the chapter. Which one was it again?
Linear regression.
Linear networks, right? Linear networks, linear regression, concise, and then this is a markdown document, and the source. This is not the source. The source is maybe inside of here. No. Like the, or maybe the notebooks are additional. Book deploy demo.
It's not along with this.
Books with Jupyter notebooks. This one is, I think, the 13 hours ago.
Can you add D12 notebook read me?
Huh? Docs. No, okay, so okay, automatically generated notebooks for Colab.
These might be like if you click on it, it directly go to Collab.
Here or
Yeah, any folder.
no? It's
Automatic.
I just wonder how they're from. What is like the source from which they're generating the notebooks?
Okay, this I think like there is an option to push directly from Colab to GitHub. It should be like that. Like Colab, if you take it, there is an option, right? Push to Git.
Yeah, but then how, like, what's like the canonical source, you know, for all of this? Like, what is their,
Yeah, underlying program that.
like, where are the, is this the ground truth for everything? Or this, or is there like I think this one is the ground truth, but then I wonder how they're generating the notebook from the markdown file. Because they're also including the import and not import but install.
No. This is not like the mark.file file doesn't have the code. It's only you cannot run the code. It's like the snippet in the notebook we see in the HTML. Like we always take it to Colab and then run it, right? Or copy paste.
Yeah.
This markdown, they have like somehow colored that background, something that they've written.
I mean, we could also read it directly from GitHub.
Yeah, but then we need to keep skipping begin a tab like TensorFlow, PyTorch.
Yeah,
The other place we can just select the tab and then understand. Otherwise, it can be confusing sometimes.
True.
Okay. You have to refer all the 3 codes.
Also in Gluon.
Yeah.
The fully connected layer defined in the linear class. Note that it has this one's feature dimension, which is 2, and the second one is the output feature dimension, which is a single scala and therefore 1. Okay, initializing model parameters. Before using net, we need to initialize the model parameters, such as the weights and biases in the linear regression model. As we have specified the input and output dimensions when constructing an n-linear, now we access the parameters directly to specify their initial values. We first locate the layer by net 0, which is the first layer of the network. Okay, because net is sequential. Okay. And then we use weight data and bias data methods to access the parameters. Next, we use the replace methods uniform and fill to override parameter values. Uniform. What's uniform?
Uniformly distribute the weights 0,
Oh.
0, and 0.1.
Also, not like a normal distribution, right?
Yeah, not like a normal. I think there can be, instead of uniform, normal also should work.
I don't understand the uniform. Okay, so there must be PyTorch documentation.
Yeah.
Okay, so uniform distribution. Oh, okay.
We can see if there is similarly a normal underscore.
There is probably normal
Yeah,
PyTorch.
there is. So this means that it is a uniform distribution. Okay.
Okay. Defining the loss function.
Yeah. Defining the loss function. The MSC loss. MSC is mean squared error loss class compute the mean squared error, also known as squared L2 norm. In default, it returns the average loss over examples. Okay, loss equal to nn dot MSC loss. It's an inbuilt function. Defining the sorry.
Built-in, sorry.
Defining the optimization algorithm. Mini-batch, stochastic gradient, and related variants are standard tools for optimizing neural networks, and thus PyTorch supports stochastic gradient alongside a number of variations on this algorithm in the Optim module. When we instantiate a SGD instance, we will specify the parameters to optimize over, obtainable from our net via net.parameters, with a dictionary of hyperparameters required by our optimization algorithm. SGD just requires that we set the value learning rate. Here we set it to 0.03. Okay. So I think all these optimization algorithm, random forest, SGD, everything will come like torch.optim.sgd or RF or gradient like that. And parameters are the hyperparameters, learning rate, epochs. No, learning rate is separately provided. I'll just see what are the net.
Parameters like here, sorry. Parameters is like the
Oh, the weights we supplied.
yeah.
Okay, got it. Yeah, weight and bias.
I'll get something to drink. I'll be right back.
Okay.
You don't feel hungry?
No, I had lunch, so.
Okay. I'll be right back. Did you notice the Apple Developer Conference?
No, I'm not a Apple fan because I've never had any like Mac or iPhone or anything of that sort.
Yeah.
So I'm not there in any forums which even talks about Mac or
Okay.
Apple.
Okay, it just seems hard to avoid. Like it's like even when not owning Apple, but
Yeah, before the coronavirus, I had an invitation to attend um, Kaggle Days in Dubai.
yeah.
Like I told them I can't afford because I don't have a job. Then they said they'll fund me completely. They provided, like, they even sent me a letter for the visa application, but then the coronavirus took everything down.
Oh, so like for a visa for Dubai or
For 3 to 4 days, 4 days I think,
in Dubai or?
in Dubai.
Hmm.
Yeah, so they were providing the flight tickets and then the hotel stay, everything.
Okay, crazy.
Yeah, but
Oh.
I lost the chance. And there was a session from Harvard with Professor Fefeli also. Like
Oh,
it,
okay. So she would also have been there.
yeah.
Hmm. Hmm. But I would have never met you.
You wouldn't have gone?
I don't think we would have met. Like, I don't think you would have been interested in this.
Yeah, maybe. But
I don't know.
this is, yeah, this would have happened even like I didn't start coming reading this because of the virus. Even before virus, my life was the same. So many people comment like it was all going out. I was always inside.
Yeah, me too. Okay, but um, maybe you would work at Google now, or um,
And I don't think that I don't see that happening.
um, so this is clear, right?
Yeah.
Okay, training. You might have noticed that expressing our model through Gluon requires comparatively few lines of code. We did not have to individually allocate parameters, define our loss function, or implement stochastic gradient descent. Once we start working with much more complex models, Gluon's advantages will grow considerably. However, once we have all the basic pieces in place, the training loop itself is strikingly similar to what we did when implementing everything from scratch. To refresh your memory, for some number of epochs, we will make a complete pass over the dataset, trained data, iteratively grabbing one mini batch of inputs and the corresponding ground truth labels. For each mini batch, we go through the following ritual. Generate predictions by calling net of x and calculate the loss L of the forward pass. Calculate gradients by calling L.backward, the backward pass. Update the model parameters by invoking our SGD optimizer. Note that trainer already knows which parameters to optimize over, so we just need to pass in the mini batch size. For good measure, we compute the loss after each epoch and print it to monitor progress.
Okay.
So,
So
yeah.
first we iterate through the number of epochs and then find the gradient and then back propagate and then trainer dot step. Where okay. Can you check like trainer and backward? Where did it come from? Which
Trainer, sorry.
library? Yeah, trainer and backward function. It's from PyTorch. Some
So loss is from the MSA loss.
loss is from NN module. So I'm just thinking trainer and backward.
Trainer is from Torch Optim
Oh, okay,
SGD.
okay, this one. Okay, yeah. So
Um,
when you, a trainer is like a feature of the Optim algorithm, also
yeah,
backward. No, backward is the function of a loss.
yeah.
Okay. Trainer dot zero gradient means that is where the training is actually happening. Training means finding the gradient.
Yeah.
Then you'll back propagate, then iterate to next step, find the loss, find the net loss. Okay, that's what happens in a training process.
So I think the actual training, like the weight and bias change is happening here, right?
Yes.
And,
It is combined in that step. The weight and bias are combined in that step.
but then I don't understand. Note that the trainer already knows which parameters to optimize over. So we just need to pass the mini batch size. Where are they passing the mini batch size? I don't see that. You see that?
I think the epoch is the next mini batch.
Yeah, but here they are saying, so we just need to pass them in the mini
Yeah,
batch size.
the data iter w y is
Okay.
the
Mm.
can you go back and see what is data iter? I what was it that we did, that data loading and array of
Here,
feature and label, yeah,
they
and the
define the
batch
batch
size.
size. Yeah.
Okay, so here X will be for label and features and labels.
Sorry. Mm.
Bless you. Yeah. So see, in the for loop there, we are using for X, Y in data iter. Okay. So X is for feature and labels, Y is for batch size.
Why is for batch size?
Yeah. Now just keep this line in your memory and come down to the code we were checking. Yeah. So for X, Y in data iter. So X is network of X, that is feature and label, and Y is the batch size.
No. Why is the batch size? No. Why is the label?
Oh, okay. Y is the label. Then batch size, I think they get it from,
No,
how
I
do
think
they,
this is confusing. Like because here they're saying that they need to pass in the mini batch size, but there's no mention of the mini batch size in this code snippet, right?
and mini batch sizes inside data iter, the information about the mini batch size is there.
It's already included, but why do they mention it
But
here? Like,
yeah, so but how do they extract it? We are not sure.
so how the loss, how the optimizer knows
Yeah,
about
I
the
think
mini batch
the
size?
trainer, or I think the trainer will already know about how to extract parameters and image mini batch size. That's what they say by the sentence. Note that the trainer already knows which parameters to optimize over. No, so we just need to pass the mini batch size.
Yeah, so like it already knows about the parameters, but it doesn't know about the mini batch size. At least that's what they're saying here. And then,
But we know it is mini batch is also,
but how would the trainer know about the mini batch size?
it's in range, XY in range, or just in data iter. For XY in range,
But how does the trainer know about the data iter? Like,
I think it's confusing.
maybe it's just maybe
Maybe
that. Yeah, sorry.
I think if you print like x dot batch mini batch size, we can see if the mini batch data is contained in X or Y. We need to run this code and we need to print.
See, I think they're talking about the MXNet, and in MXNet they're giving the batch size to the trainer.
Okay. In PyTorch, it is given.
And
Input.
PyTorch, it's inferring it from somewhere, like
It's implicit.
yeah, it's somehow it's implicit. Should we try the Colab? Bias data. Okay, so it's working, like, but
Yeah, can you try to print X dot mini batch size or something like that inside the for loop?
here, like print
Yeah,
X.
print X dot mini batch size.
I don't think that will be no,
Or
that won't be a method there. Like we can check what's like
what's X? DIR is?
okay, so this is a long list. It has a lot of methods to find. M, it would be under M.
I think we can move on. It's okay. We understood. We don't have to pass mini batch size.
Okay, like I don't know. I mean, I understand basically what it's doing, but I don't understand exactly how it's doing it in detail. Like I don't know how the
back end, like that's like we don't know like how PyTorch handles it. You're not
okay,
able to
so wait. So this one, the trainer gets the parameters, right?
Yes.
So the weight and the bias, and
Yes.
they have a gradient attached.
Yes.
So when I call loss backward, the gradients will be populated here, right?
Yes.
So then it does trainer step, and it already knows.
Trainer step is actually updating the weights.
Yeah.
Iterating to the next weight.
Yeah, and what about the loss dimensionality? What's the loss dimensionality? We could actually check that. We can do like print L shape. But since the loss is also
here we are using a zero gradient, right? Why zero? Because
because it would accumulate.
Earlier we were using auto gradient.
Yeah, it's still using auto gradient. It's just zero. It just resets the gradients to zero because otherwise it would accumulate.
Accumulation problem. Okay.
And then trainer step. So I think the only thing I'm still wondering about is some. Okay, so I guess this is already doing the sum. The torch is already doing the sum on. We don't need to do the sum, right, of the error.
Yeah, in the trainer module, the summation is happening. Not trainer module, loss module.
In the loss mode, yeah, right.
Yeah.
Okay, so
I think I remember reading they take the mean. MSC loss takes the mean, right? Mean sum.
oh,
Mean sum.
mean squared error.
Yeah, mean square. In the mean square, that summation is happening.
Okay. But this should be the exact same implementation as the from scratch, right? So it should just be sum. The error, the loss they define here.
Oh no, it's because they use the mean MSC loss. You can, if you were using an L1 norm, it will be exactly same as the step-by-step implementation.
Okay. Okay. Okay, I get it. I get it. I get it. Below, we compare the model parameters learned by training on finite data and the actual parameters that generated our dataset. To access parameters with PyTorch, with Gluon, we first access the layer that we need from net and then access the layer's weight and bias. To access each parameter's value as a tensor, we invoke its data method. As in our from scratch implementation, note that our estimated parameters are close to their ground truth counterparts.
That means the loss is very less.
Yeah.
Okay.
Um, very little. Yeah. Summary.
Summary. Using PyTorch's high-level APIs, we can implement models much more succinctly. In PyTorch, the data module provides tools for data processing, and the NN module defines a large number of neural network layers and common loss functions. We can initialize the parameters by replacing their values with methods ending with underscore. Okay, that's why normal underscore, binom, uniform underscore. I think like in data module, there should be one hot encoding, label encoding, all the pre-processing steps will be there, filling NA values.
It's another chapter, or?
No, I'm just saying because they have written there, right, in the summary, data module is for data pre-processing,
Oh,
data
okay, yeah.
processing. So all those one hot encoding, label encoding, and all such things are data processing.
Ah, okay, yeah.
And NN modules, like it will have the neural network and the loss function related terms.
And then also the methods ending with an underscore, that's for
That's for NN modules.
initializing the parameters.
Yeah, initializing parameters is related to NN module, right? It's not related to data
Yeah.
because we like pre-processing doesn't need any parameter initialization. You understood?
Yeah. I just was I was always wondering about the underscore, the trailing underscore.
Yeah, that the one we used, right? Uniform underscore, normal underscore,
Yeah.
that one.
Yeah.
So if we want to use a particular method, we have to use an underscore to it. That is what is mentioned there. So we wanted a normal distribution, so we used normal underscore.
I don't really understand why the underscore, like what's the convention there? Like
It's because it's a method. Like you can, PyTorch actually has another module called uniform or normal.
Yeah.
that we can use with arrange functions like arrange, right? But
Mhm.
this underscore will be specifically to neural network module, NN module. So when
Okay.
you're using these methods in an NN module, you need to refer them by calling the underscore.
Here.
Yeah, that one.
But data is just a tensor, right? So it's just a PyTorch tensor. Let me check. Like, so it's no wrapper or anything. So it should also like, why wouldn't it work if I just say uniform? Oh no, I think I get it. Like the underscore is when it's replacing. So it's kind of like you were hinting in the right direction. It's like I wouldn't be able to use this because then it wouldn't replace this.
Yes, correct. Like it wouldn't be a uniform distribution then.
Yeah.
You are, it's kind of reshaping the data to a uniform distribution. Not exactly reshaping, like reforming. Maybe the word
This is not
reforming.
even like there is not even a version without the underscore. Maybe.
I think it should be, yeah, it's there
No.
without underscore. Torch dot normal. Maybe you have to give input an array.
Like the size, like.
Yeah.
It's too complicated for me now, but
No, but you understood, right? There is a
yeah,
normal function specifically for torch and a normal underscore for data and NN modules.
for replacing.
Yeah.
Okay.
So exercises, if we replace nn.msc loss reduction equal to sum with nn.msc loss, how can we change the learning rate for the code to behave identically? Why? I don't know. Reduction equal to sum. What are they referring by reduction equal to sum?
It's also not really. They're not using that. Like
Yeah, I
basically, they're
think
giving
we
an
can.
exercise.
Yeah,
Doesn't
we'll
make
skip this.
sense. I mean, the
We'll give the
exercise probably makes sense if they're like.
in a model, in a actual model, but one line question doesn't make any.
Wait, we could change it like this. We could check. No, it doesn't. Like they're using the same learning rate. That we were using in the from scratch, right? We were also using 0.3. And so the error is like 0.1. The
It's
loss,
more.
I mean,
It's
it's
more.
yeah. And
Okay, we have to use maybe zero instead of 0.03. We have to increase the learning rate because we are summing.
okay.
To our goal is to bring the exact same loss. So
Yeah.
how can we obtain that? That is what they ask. Now we have increased the learning rate. Loss has increased. So we have to decrease the learning rate.
Okay. Wait. Okay.
Oh.
Also, what here we were also using the sum, right? In the from scratch. Here it says loss sum backward, and then here it's a learning rate of 0.03, and
Number of epochs. You change number of epochs.
oh, I'm changing number of epochs the whole time, right? Okay. Or just this time? Mhm.
Yeah, it was just this time.
Okay.
Learning. Mhm.
So why is when I run this one here, the from scratch, why is the loss better here? It should be the same.
Can you go back to the other one? But if you see the third epoch, in the third one, the loss has increased for scratch one, right?
The third one? Here, yeah.
Yeah. In the third epoch, it just shooted up. Oh no,
Yeah.
it became lesser. Okay.
Yeah, right. And then here it should be the same exact implementation.
There it is not uniform, right? For scratch, we are using normal, I guess.
For the weight initialization?
Yeah. I'm not sure. Yeah, here it's a normal, but here we used uniform. So
wait, where is it? Here.
yeah, that one,
Uniform.
normal. You have to make it normal.
Okay.
Yeah, that one. Data dot normal underscore.
And then it's the same. The rest is the same, right?
Yeah.
Okay, now the loss is actually declining, but it's still not as good as here.
Because normal distribution is also again a random thing, right? So you may not get the same if you run the next time.
Here, and the
Yeah, this one, if you run the next time, you may not get the same loss.
no, but it's very similar. And here it's still not as accurately as.
So I think you need to keep changing the learning rate, because they have asked the question, right? What needs to be, there is something that is affecting with the learning rate.
Man, this is not a good look on Amazon,
like you can change to 0.9. Don't make it like 0.09, but 0.0, the learning rate, LR rate. In this tab, top above the cell above, yeah, that one, 97, cell number 97, LR equal to 0.09.
yeah.
Can you make that?
Oh, but it's the same, right?
No, 0.09. It is 3, right? Make it 9.
Okay, but the why? But the implementation is the same as here, right?
It could be a difference in the normal underscore function and the normal function. Some kind of small change could be there.
Okay. Okay, so it could be a bunch of things, like, I guess.
Oh.
But like tweaking the learning rate. doesn't seem to make sense because here we're having like okay, actually this one is better.
Mm-hmm.
So
What about 0.01? Yeah.
even smaller. But I think their exercise, they were like asking for like a theoretical solution.
Now this is again same to 0.02. Theoretical I don't think we can provide because it's some internal thing that's happening between normal underscore and normal.
Yeah, wait, if it's like a reduction sum, it's something like if we would graph the error, right? If we would like say MSE graph mean squared error. Some squared error. This would be really good as a visual. Mean squared error, sum of squared error.
In the question, it's not about sum of squared. It is mean squared sum. Like reduction is sum. There is some difference.
I think it's the same. Like I think that's just the way it's implemented. Like this one is like a sum of squared errors, I think. Or you think it's something else than just a sum of squared errors?
No, because they are using an MSE loss and inside that a sum of squared. Or can you like we'll find what is the
But is there
documentation for NN dot MSE loss. It will
yeah,
give us
at least like this Google search shows there's no SSE loss, like some squared errors loss. Yeah. So there's only this one, so it could be PyTorch could be that they bundled the reduce deprecate reductions.
yeah, here str equal to mean. Oh, okay. So can you go up? Yeah, here can you see MSE loss is the function name, but the way you want to do the loss function, str is mean by default, but if you want to make it some SSE loss, then you have to change to sum.
Okay. Do they even mention SSE loss?
No, because this factor str is changing the MSE loss function to SSE loss.
Okay. And then and then how does it behave differently when for the derivative? It's like mean squared. So I think this one here, sum of squared errors, it will be bigger numbers, right?
Yeah.
So
because mean squared is an error of one mean value.
yeah.
But sum is like a very big, like a combination of all the errors. So it's a big value.
So the learning rate would have to be higher for sum?
Learning rate. Actually, it shouldn't
Or
vary
smaller?
because learning rate has nothing to do with, it's like, what do you say? It's like the way our value, we see the loss. Like we have to understand it's a sum value, and we can consider the sum will be a higher value, and
Yeah.
mean will be a lower value.
Okay, I think for the SSE, the learning rate has to be higher. Lower, sorry, lower.
Okay. Yeah.
To make
If the
smaller.
learning rate slower means number of a number of instances are also lower, right? So number of
Yeah.
elements that we sum is also low. So the error will be low.
No, the loss will be higher with the squared, with the sum of squared error loss.
Correct.
So to make equally small changes to the weights and biases, I'd say we should decrease the learning rate.
Yes, correct.
Okay, but then the collab is like what?
I think like this will show greater change when you have a bigger data set. Now we are using only 1,000 samples, no?
I'm dissatisfied with the collab because but I wonder if there will, like, in the next version maybe there won't be, or maybe even in the one I downloaded. I'm dissatisfied with this free resource they gave me for free.
Level
Okay.
of dissatisfaction.
There's a Reddit subreddit, choosing beggars. I feel like the authors could quote me there, like, okay, so now it's working, right? Now there's a equally low error rate. Then, like, it's the same as the from scratch. And now they're using a learning rate of 0.3. And they're not using the reduction sum. They are using the
mean square.
Yeah, right? Where is it? Here, yeah. So let's see what happens now. Now the error should, the loss should skyrocket, should be more loss. Yeah. And now I was saying we should reduce the learning rate, and
yeah,
0.03. Yeah, maybe even more, maybe even like this. No, but maybe less.
But when we increase the when we increase the learning rate, we found a similar match to the from the scratch one. Like we were using 0.02, 0.01, they gave more similar values.
Increase it or decrease it? Just
it was 0.03, right? So making 0.02 is actually increasing.
Yeah. You mean like this, 0.02?
Yeah, correct. Yeah, now it's like
No, I would say it's similar. No, I would say that's similar to the bad values we've seen before.
Okay, now 0.06 is again, you have decreased the learning rate.
Increase.
No, 0.03, when you make it 0.06, it is decrease.
Okay, okay. Okay, I'm confused now. Hmm.
You decreased, loss increased.
Okay. So first, I'm confused by the fact that if we use 0.03, like if we just load this in, if I
Now you have
reload,
used 0.00.
if I just open this, as written by the authors. If I just open this as written by the authors, it's the same learning rate as in the from scratch. 0.03. But then here they use the mean squared error, and here they use the mean squared error reduction by sum, right?
In the scratch one, they are using sum of.
Yeah, here they're using sum, also with the learning rate 0.03.
I don't think so, because if you use sum, yeah, they are using sum.
Yes.
Correct. They are using sum.
I'm confused. And then here they're using the same learning rate, but with a mean squared error. But in the exercise, they are saying that that there should be a difference, but then they're proving with their work that there must be no difference. Like, okay, dude.
Oh, 1 minute. They have. Can you go back to the question? The question is exercise.
Yeah.
Yeah. So, how can we change the learning rate for the code to behave identically? Okay. So they say there is a change.
Yeah, but we're running it, and it's already behaving identically.
I don't know. I'm not. Maybe it is the problem with 1,000 samples.
But I mean, like, we're having 1,000 samples in both, right?
Yeah, that's what the sample size is very low, that whatever significant change they would have been expecting is not coming here.
Oh yeah, but like there is a change coming, but like there must be like a wait. This mean squared error must be like
Again, here you have to make it normal, the weight normal distribution.
right, but when I run it, like without changing anything, right? Just run it as they authored it. Then I get like
Lesser value for loss.
yeah, it's okay. Like
What's the last question?
no, there is the second one is if we should review the PyTorch documentation to see what loss functions and initialization methods are provided. Replace the loss by Huber's loss.
Okay, that's what str. By changing str value, we can change the loss functions. Huber's loss will also have a keyword like Sum is the keyword for SSE loss. MSE is by default. Hubers will have sum. I will just check what is Hubers. I hate this. My laptop is always stuck.
Is it because of Zoom or?
It happens when I'm using Zoom. I'm not sure what the relation is.
Does it also happen with Google Meet?
I haven't tried.
Yeah, okay, maybe.
But it never happens with Hangout, the Hangout video call we make.
So Google Hangouts?
Yeah.
Okay, yeah, so maybe we should switch to Google Hangouts.
No, I haven't checked about Google Meet. So, yeah.
Isn't that the same?
No, Meet and Hangout is like Hangout, only you and I can call. Meet means we can have more number of people.
No, it's also in Hangouts, you can also have more people.
But only for, I think for 30 minutes. Because I was having a call with my friends and then after 30 minutes, the call had hung.
Okay.
I don't know. I think for Huber's loss, we have to do a separate like implementation itself.
Can you find the PyTorch documentation on Huber's loss? Huber loss. Oh, so it's called the smooth L1 loss. Okay. Also known as Huber's loss. Okay. Are you looking at the screen share?
I'm stuck at a page. I'm trying to bring it back.
Okay.
I think it is because like multiple icons of Zoom are open, like chat. Then
okay.
maybe because of that. Yeah. Now it is.
I'll
I'm
get some
slowly
water.
getting back. It's okay. Like we'll stop for now because. Hello.
Yeah, let's just finish the exercise.
Yeah.
We'll not discuss them when it's finished. So you have a pretty old notebook, or?
We got it 3 years back.
Okay, so it seems fairly new.
Yeah, but it was not a very costly one, although it's an i3 core.
Okay.
And
yeah,
because
okay.
if it was Windows, it would have stopped working in this performance by now. But since it is Ubuntu, it is going on.
What about Chromebook?
I don't know.
It's too slow as well.
Yeah, I've never seen anybody using it here.
Okay.
Okay, so here smooth L1 loss. It creates a criterion that uses a squared term if the absolute element-wise error falls below 1 and an L1 term otherwise. Okay, L1 loss is finding the sum of, finding the absolute value of the losses. So if the absolute value of the loss is less than 1, we need to use a smooth L1 loss. And it is given by 1 by n summation of Z1, where Z1 is 0.5 into xi minus yi whole square. Here xi they mean the ground truth, and yi is the observed value. Okay, it's not any feature and label.
Oh, okay. Xi, they mean the ground,
Yeah.
the output of the network.
Yes. And so xi minus yi, if it is the absolute value is less than 1, they multiply the difference squared with 0.5.
Oh, it's great that they add to the confusion.
And if it is otherwise, they will minus 0.5 from the absolute value.
Okay, so meaning if their error is really small, they will amplify it, and otherwise it will just.
What is the de-amplify, or it will make it the opposite?
No, it just will. It will not really change it if it's bigger. If it's a.
Yeah. So that's when we use Huber's loss. So for Huber's loss, there is a smooth L1 loss function, right? Okay, it has every parameter same as MSE loss. Just the function name is different.
Okay. So we can just try to use that.
You can just close the bracket.
Oh. Okay. Then you. Okay, so this actually works better than the sum of squared errors here.
Yeah, because after each epoch, the loss is decreasing, right? When the loss value is decreasing, Huber loss performs better.
Okay. Replace the loss by Huber's loss. Okay. How do you access the gradient of net zero weight?
Then we had a function, no? Describe, no, not describe.
I think it's just grad.
Yeah, grad. Yeah. Yes.
Yeah. Okay, that concludes this chapter. You wanted to stop, right?
Yeah, we'll take a break for 1 hour.
Yeah. Okay.
1 hour or 1.5? I have to make dinner.
Just take your time, and then whenever you feel ready, you message me.
Okay. Yeah, I'll try
Roughly,
to.
roughly 1.5 hours, right? Roughly 1.5 hours.
Yeah. Okay then. Bye.
Let's say roughly 2 hours, because I think more conservative estimates work better. Okay. Yeah.
Okay. Yeah.
Okay.
Bye.
Bye.